Salim Mohammed, and I'm excited to launch a new series called Technology Overview Series, which is planned to give you enough information about LAN SAN Convergence so that when we are ready to launch Dell Networking S5000, you're comfortable on this topic and you can not only talk about S5000 in front of your customers, but also can have a very engaging discussion with the customers about other assets that Dell has to offer from LAN SAN Convergence space. Now going back to the current view of data centers, what we're showing here is a couple of servers which in a very simplistic environment today have two NICs that are shown in black, and they have two HBAs. And I've shown HBAs in blue and red color to show that these are physically separate dual rail kind of connections going into FC switches. So here are two servers, and then from LAN side you have two top of rack switches that are connected to a LAN cloud, and on SAN side you have FC switches that are connected to Fabric A and Fabric B. Once again, please notice that there is no connection in between these two, and these two networks, Fabric A and Fabric B, will continue to remain separate throughout. So how are they connected today? Each server NIC is connected to a top of rack switch, like this, and like this. Now this completes our LAN connectivity. From SAN perspective, you have one adapter which is connected to one FC switch from another server. Another HBA is connected to another FC switch. The second HBA is connected to a completely separate FC switch as shown right here. And as you can tell, this separation or air gap is maintained throughout the network in FC SANs. Now, when looking at this environment, we can obviously see that it's a fairly inefficient way of building the networks from an IT administrator perspective when it comes to cost and the efficiency inefficiencies that are involved in this. As you can see, there are 4 switches, multiple cables, multiple adapters, and a lot of data center infrastructure space which has been wasted in maintaining 2 or 3 separate networks. So as you can imagine, IT administrators have been looking for some solution to this separate existence of networks for a long time. It goes way back. As early as 1994, Tandem Computers tried to solve this problem with an initiative called ServerNet. Very quickly, that initiative was divided into 2 separate discussions or initiatives. First one was Future IO. IBM, Compaq, and HP joined that group. The second initiative was NextGen IO. Microsoft, Intel, Sun joined that particular group. After making some attempts and trying to gain momentum, those 2 initiatives were then converged back again in 1999 in an initiative called System IO, which in the same year was then renamed as InfiniBand. And as history tells us that InfiniBand was a fairly disruptive model, even though it was very initiative, but it was disruptive because it required a change in physical media and changes to OS middleware. As a result of that, InfiniBand has not been widely adopted in the market. It has found a specific niche in the market in high performance environment where reducing the latency from milliseconds to microsecond and beyond is important. So it has a niche, very comfortable niche, but it's not a commonly deployed storage protocol. Then in 2003, industry made another attempt by using the ubiquity of Ethernet and letting SCSI protocol ride directly on top of Ethernet over TCP/IP stack. That initiative has been gaining momentum ever since. iSCSI is growing very strongly, and initially starting from SMB space, now it is going more and more towards larger enterprises as well. From Dell perspective, we have a very nice story to tell from iSCSI perspective to our customers. However, in parallel, later half of last decade, another protocol was initiated. It's called Fiber Channel over Ethernet. And the goal of this protocol was to ensure that customers who have infrastructure investments in fiber channel space, they're able to make use of that investment as well. As we know from iSCSI, that people who have adopted to fiber channel, their tools, their management, the management tool and FC infrastructure was not easily portable to iSCSI, whereas FCOE tries to solve that problem. So now let's look at the data center view. Once again, the previous view is here, or today's view is here, and this is where we're wanting to go with the deployment of FCOE. Same picture from the top. You still have a LAN cloud which is connected to two Ethernet switches. You have a fabric A showing FC fabric connected to one of the switches. You have a fabric B showing another FC fabric connected to the second FCOE switch. These two switches are Ethernet switches, but they are FCOE aware. And then you have the same two servers, but please notice this thing. In the previous example, we had two NICs and two HBAs. In this example, we have two CNAs in each server. The way physical connections are made is one physical wire going from one CNA to one of the top of rack switch, and another one going like this. Same is true from this perspective as well. So from wiring perspective, you can look at the reduction in number of wires or number of cables in this environment as well. However, when we look at the type of traffic that is flowing on this link, from server perspective, the server OS still sees an HBA behind both of these CNAs. So from server OS perspective, all of the tools, all of the configuration that they used to do from software on this type of deployment, they're able to do on this type of deployment as well. On the wire, you have LAN traffic, but at the same time, you have FCOE-based SAN traffic flowing on the same wire as well. So same cable for LAN as well as SAN. But once again, please make note of this, that even though the traffic is being shared, but from the perspective of a storage administrator, the air gap which is maintained in FC switch A or FC switch B or fabric A, fabric B is being maintained in this new environment as well. The only thing that changed is instead of 4 switches, we have 2 switches. Instead of 8 wires or more per server, we have four wires that are coming out, right? Actually, 2 wires coming out. And from adapters perspective, also, just half the number of adapters that are required. The advantages that customer gets is that they can connect to their existing FC SANs, so they can make use of the existing investment in the FC storage. They can continue to use the same FC management tools, but as a result, they reduce the number of cables, they reduce the number of adapters, they reduce the number of switches, and as a result, low power consumption, low cooling requirement, and all of the power advantages. With that, we conclude our first overview session. Please join us back for the second session in the next video.